Okay, B, page 5, trig equations and identities. The population of grasshoppers after t weeks, where t is between 0 and 12, is estimated by this function here. Find the initial estimate and the estimate after 5 weeks. So the initial estimate just means that you put t equals 0 in there and then see what you get. Okay, so if you put t equals 0 in there, the sign is the sign of 0, which is 0. And so basically the initial estimate is p equals 7,500. The estimate after 5 weeks. Then you would put 5 in for t, and then you would have the sign of pi, 5 pi over 8. Okay, and then this, of course, you're going to have to use your calculator for this. So why don't we put it in the equation here. So 7,500 plus 3,000 sine of pi, where's pi? Pi times t divided by 8. Okay. And of course it's not going to show up because this is like a huge function. So we need to do a zoom fit. Oh, it did fit. Oh, but it's because I have something else in there too, I think. Let's do zoom fit. There we go. All right. All right. And then to find the value after 5 weeks, we are going to use the table actually. Okay, and we're looking at y1, not y2. I forgot to erase the second function. So let's look to see what y1 equals when x equals 5. It's 10,272. 10,272. What is the greatest population size over this interval, and when does it occur? So we're talking about between 1 through 12. So 1 through 12. Let's see where the greatest population occurs. 1 through 12. Let's see. I see 6351. I see 9621 is the biggest one. I see 10,500 at 4. So maybe it's at t equals 4, there's 10,500. But let's check to see if that's really the maximum. So we're going to set the cycle to x max is going to be 12. Okay, and then we're going to get rid of the second, that function right there, and then we're going to graph again. Okay, now we're going to use the calculator to figure out what exactly that maximum point is. So we can do that with second calc. And we go to max, and then we move the cursor to the left side of the max, hit enter, then we move to the right side of the max, and we hit enter, and it tells us that the answer is okay. So I guess what we said before was the right answer. That is the maximum. When is the population 9,000 and when is it 6,000? Well, first let's look at the table and see if we can see it on the table. 9,000 and 6,000. No, it is not clear. So what we're going to do is, for y equals, we're going to make a 9,000 line and we're going to make a 6,000 line. And then we're going to see when they intersect with the sign. Okay? Now we have the sign and we have two lines going through, one at 9,000, one at 6,000, and we're going to say, when is the population 9,000? Where are those intersections? When is the population 6,000? Where is that intersection? So let's find that intersection right there. So we'll go to intersect, which is number 5. And then we'll say first curve, yes. Second curve, 9,000, yes. And then we're going to guess, we're going to move the cursor closer to the first intersection, and we'll say enter. And the first intersection is at 1.33, y equals 9,000. So one of them is 1.33. And then the other one, second calc, intersect 5. And then we'll go all the way. Oh, the first curve is that one, yes. Second curve is that one, yes. And then the guess, let's move it closer to that one. And that is at 6.67 is the other point. What about 6,000? When is the curve equal to 6,000? So we'll do second calc, intersect 5. First curve is the sine wave. Second curve is not 9,000. We want the other curve, which is 6,000. Enter. Where's your guess? Doesn't really matter because there's only one intersection point. So the intersection is 9.33. During what time interval does the population exceed 10,000? So let's see. Let's make one more line, or we can get rid of these lines. We'll just make a line that's 10,000 now, because we want to know when is it more than 10,000? Oh, graph. Okay, there's 10,000. Oh, so we'll find out where this point is and where this point is. So the way we do that is we're going to use the intersection also. Number 5. First curve, second curve, guess. And so first we're going to go over to the first intersection, hit enter. And it's going to be 2.51. 2.51. That's the initial time, and then we'll find the time when it stops being 10,000, which will also be found using second calc. And intersect. First curve, second curve. And then we'll go closer to this intersection. And it's 5.49. Okay, so that's when it stops being 10,000. So the time interval is t, I guess, is that. Okay? Number 3. The model for the height of a light on a certain Ferris wheel is, and they give us this formula, where h is the height in meters above the ground and t is the minutes. Where is the light at time t equals 0? Well, you just put t equal to 0, and then this whole thing becomes 0, including the sign. Minus 19 is multiplied times 0, and you're just left with the initial value of 20. Okay? Okay, and then when we type this into the calculator, the first time I did it, I made a mistake. I put plus there. It's going to be minus, okay? Now when I graph it, there we go. Okay, so it says, at what time is the light at its lowest in the first revolution? So we're looking for this point here. So we could do second calc minimum, number 3, and then we're going to go all the way over there, a little bit to the left of the intersection, or the minimum point. Then we go a little bit to the right and hit enter again. And that's our guess. And it'll tell us that the minimum point is 0.75. Okay, so I had made the thing backwards before. 0.75. Okay. And then how long does the wheel take to complete one revolution? We can use the formula P equals 2 pi divided by B, because we do have a B value here. If you look at that, the B value is 2 pi over 3. It's the coefficient for the t term. And so you put 2 pi over 3 in the denominator, and then you end up with 3. Okay? And then I sketched the graph of this function, and I drew it backwards because it's really like that, right? Starts at 20, goes down to 1, and then it goes up to 39, and then it goes back down. Okay. Number 5. A paint spot X lies on the outer rim of a wheel of a paddle streamer. The wheel has a radius of 3. It rotates anti-clockwise at a constant rate, and X is seen entering the water every 4 seconds. So remember our general cosine formula. It looks like that. Let's try to figure out if we can. Let's try to figure out A, B, and D. Okay. So for example, A we can figure out is 3 because the radius of the wheel is 3. It's going to be going up 3 and down 3. Okay, so A is 3. B, we're going to use the fact that the paint spot X is entering the water every 4 seconds to say that the period is 4 seconds. And then based on that, we can figure out B. B is 2 pi divided by the period, which is pi over 2. Okay, and then D is the height of the center of the wheel, which would be 3 plus 1 is 4. Okay? And then the last thing we need to figure out is C, and now we use the fact that it says at time t equals 0, x is at its highest point. So that means that it's the cosine is not shifted at all because I'm going to try to redraw this. Okay. Oops. Oh boy. Okay, so let's say the paint spot enters here, and then it goes up, and then it comes down again, and then it enters here again, right? Okay, but so where is the beginning of the cosine wave? The beginning of the cosine wave is right here, and so it says at t equals 0 that the paint spot is at its highest point, which is 7. Okay, and so let's see. Now they say, at what times does x first enter the water, which is this distance here? So we could put it in the calculator, and we're going to put our new. And let me write out the whole thing. So we have h of t equals a is 3, cosine, and b is pi over 2, c is 0. And D is 4. So I'm going to put this in the calculator, and then we're going to figure out when it first goes below 2. So it's 3 cosine pi over 2 x divided by 2. It's better to do it like that, by the way. Put the division last so that you don't need to put a bunch of parentheses. 4. Okay, now we're going to graph. Okay, so now we're going to draw a line at x equals 2 because that's when that's where the water level is. 2. Okay, and then we're going to say, okay, when does it first enter the water? And then we're going to do a second calc, intersect number 5, first curve, second curve, move the cursor over a little bit so that, great, we can't see anything. Let me do a zoom fit here. Okay, now let's try it again. Second calc, minimum, not minimum, second calc, intersect, which is 5. First curve, second curve, guess. And so now we're going to move it over. Here. 1.46, okay? So the time is 1.46.